One of the reasons I don't like FOIL is that it breaks down on this problem. FOIL works for two binomials, but if you don't have two binomials, then you can't FOIL it. And that's not such a big deal. Just remember, we were always distributing anyway, so I'm going to distribute 6x. The only thing this time, I'm going to do it 3 times. So I'm going to say 6x times 2x squared, well, that's 12x squared. 6x times negative 3x, well, that's, whoops, I messed up there, didn't I? I can't count my, let's talk about that. I got an x here and 2x is here, it should be 12x cubed. Then I take 6x times negative 3x, I get negative 18x squared. I take 6x times negative 5, I get negative 30x. Now, next I'm going to double distribute, or triple distribute, that 5. I'm going to take 5 and I'm going to distribute to that, my second parentheses. I guess we're only distributing twice here, but I have 3 terms. 5 times 2x squared is 10x squared. Well, I'm going to write the 10x squared in columns since I have so many like terms. 5 times negative 3x is negative 15x. 5 times negative 5 is negative 25. I don't care if you write that in the first line or the second line. I'm going to write it in the second line, but it really has no bearing because it doesn't have any like terms. Now let's combine our like terms. 12x cubed minus 18x squared minus 45x minus 25. Not such a bad way to do that. On example 7, I'm going to show you something called the box method. It's the same thing. It's a way to remember how to distribute. Now this one I would triple distribute because I have 3 terms in each one. So when I have more than 2, you're going to find out I like to use the box method. And this is why I call it the box method, because I draw a box. Now, across the top, I didn't make a very good box there, but across the top I'm going to put 2y squared, positive 3y, and negative 1. And then I'm going down the sides. I'm going to put in 3y squared minus 5y plus 2. Now this is just a way to remember what to distribute. So now then I'm going to multiply length and width for each box. So in the first box, I'm going to take 3y squared times 2y squared. Well, 3y squared times 2y squared, well, that's 6y to the 4th, because I have 4 total y's. Then I'll take 3y squared times 3y. Well, 3 times 3 is 9, y cubed. My y kind of looks like a g there, doesn't it? But it's a y. And then if I take 3y squared times negative 1, well, that's just negative 3y squared. Now I'll go to row 2. I'll start over again. Negative 5y squared times, or negative 5y times 2y squared. Well, that's negative 10y cubed. Negative 5y times 3y, well, that's negative 15y squared. Negative times the negative is a positive 5y. Finally, I take 2. 2 times 2y squared is 4y squared. Then I take 2 times 3y, I get positive 6y. And 2 times negative 1 is negative 2. Now that you got this box, notice, this doesn't happen all the time, but it happens a lot of times. Your like terms are in diagonals. So I'm going to have 3 diagonals full of like terms. I don't have any like terms for 6y to the 4th, so I'm going to write that down, 6y to the 4th. Now I'm going to add 9 minus 10 is negative 1, so I'll say negative y to the 3rd. Then we'll go to the next diagonal. 4 minus 15 is negative 11. Minus 3 is negative 14. So negative 14y squared. Remember, when you're adding and subtracting, we never add the exponents of the variables. And then 6 plus 5 is 11y minus 2. There's the box method. We could have distributed. You could have written it as a 3-digit multiplication problem. 3 terms times 3 terms. You could have done it that way. So whatever way you like to do is the way you should do it. And that's it for multiplying polynomials.